let's start with section 14.5, surface area. Let's go with the first example. They say find the area of the surface given by z equal f to the xy that lies above the region R. So here's our region fxy equal 5x plus 5y and R triangle with vertex 0, 0, 4, 0, and 0, 4. So let's see the first one. So here's our function f of xy equal 5x plus 5y. So first of all, I'm going to say find the derivative with respect to the x. Fxy is going to be 5, and the derivative with respect to the y is going to be fyxy equal 5. So let's first of all grab this one. Here's the vertex, which is 0, 0, and 0, 4, and 4, 0. So this is our region. We need to find the surface for this region. Now, surface for the region is going to be the integral from with x from 0 to 4, and from y, it's from 0 to this line. So first of all, how are we going to find this line? So I'm going to use the y-intercept form, y equal mx plus b, y equal, check here, 4 goes 1 and 1 to the, that means our slope is negative. If you want to choose this point and choose this point and find the slope, y1 minus y2 over x1 minus x2, the slope is going to be negative 1. And here's the intercept 4. This is the intercept. Now y is going to be equal negative x plus 4, which is 4 minus x is the same. That's mean for the y is going to be from 0 to this line, from 0 to 4 minus x. 1 plus f sub x squared, f sub y squared. This is the rule. That's why I always tell you check the slides before you doing these examples. dy dx. So it's going to be 1 plus 5 squared plus 5 squared dy dx. So 5 squared 25 plus 25, 50, and 1 is going to be 51 dy dx. The integral with respect to the y is going to be, here's y from 0 to 4 minus x. Plug in 4 minus x here, so it's going to be 51, 4 minus x. Distribute the 51, so 451, square root of 51 minus square root of 51x. Now, do the integral with respect to the x from 0 to 4, so it's going to be 4 square root of 51x minus square root of 51x squared over 2 from 0 to 4. Plug in the 4, so here is 4, and here is 4 squared minus 0. Because when you plug in 0 here, cancel everything, so this one is going to be 0. 4 times 4 is 16. 4 squared is going to be 16 divided by 2 is going to be 8. 16 minus 8 is going to be 8 square root of 51. So we're going to type here 8 square root of 51. You got it right. Let's go to example 2. Find the area of the surface given by z equal f to the xy that lies above the region. Here is the region above. R is the square with the vertex 0, 0, 8, 0, 0, 8, and 8, 8. So let's check this example. That means here's our vertex, which is 0, 8, 0, 0, 0, 8, and 8, 0, and here is 8, 8. So here's f to the xy. I'm going to find the derivative with respect to the x is going to be 8. The derivative with respect to the y is going to be negative 3. Then the integral with respect to the y is going to be from 0 to y equal 8. And with x is going to be from 0 to x equal 8. 1 plus f sub x squared, f sub y squared. So it's going to be 8 squared, negative 3 squared. So it's going to be 1 plus 64 plus 9 is going to be square root of 74 from 0 to 8 and from 0 to 8. Now do the integral with respect to the y. So it's going to be from the square root of 74y from 0 to 8. Then it's going to be 8 minus 0. So it's going to be, I'm going to take the square root of 74 as a constant out. And 8, find the integral for 8 with respect to the x is going to be 8x from 0 to 8. Then I plug in 8 here. So it's going to be 64 square root of 74. So we're going to type here for the second example, 64 square root of 74. So 64 square root of 74. We got it right. Let's move to example 3. Let's go to example 3. Example 3 is a little bit different. So if you look at example 3, they're telling you find the area of the surface z equal f to the xy that lies above the region. So here's our region, fxy 1 plus x squared minus y squared, and our region is x squared plus y squared less than or equal 4. That means this is a circle, so we have to work with parallel coordinates. So here's our region, and here's f of xy equal 1 plus x squared minus y squared. So you have two options. We need to convert to polar coordinates. F sub x to the xy is going to be 2x. F sub y, xy is going to be negative 2y. The derivative with respect to the x, the derivative with respect to the y. So our region, here is a circle less than or equal 4. That means our radius is 2. So here is the circle with radius 2, but we need to find the region for all the circles less than 2. That means all the circles here, which is less than the radius equal 2. So our radius between 0 and 2, and our theta is going to be, because we're going to start from this part, and we're going to keep going, rotate like this until go back to 2 pi. So our theta from 0 to 2 pi. Again, you have two options. You want to convert f from x, from rectangular coordinate to polar coordinate, and find the derivative with respect to the r and with respect to the theta. Or you can keep it like this. I'm just gonna go ahead and convert the derivative, because I'm not gonna use this one. So I'm gonna say f sub x is going to be f sub r, x is going to be r, y is going to be theta, 2x is going to be 2, x is going to be r cosine theta. The same thing, f sub theta, r theta is going to be negative 2, y is going to be r sine theta. Or you can go ahead from here and find the derivative with respect to the r is going to be 2r cosine theta. And with respect to the theta, f with respect to theta is going to be, so it's going to be harder for you, for theta is going to be supposed to be negative 2r sine theta, because you're going to find the derivative here and find the derivative here, also just to respect to the theta. So it's up to you which one you're gonna choose. Find the derivative with respect to the x and the y and convert these to the r and theta. We will see on the example 5, we going to convert to the polar coordinate and then find the derivative with respect to the r and theta. But you're gonna get exactly the same answer. So now here is f sub r and here's f sub theta. dy dx is going to be r dr d theta. So our surface for this region is going to be from dr d theta, so from 0 to 2 pi, and for the r is going to be from 0 to 2, 1 plus f sub r squared, f sub theta squared, r dr d theta. Then it's going to be, we're going to plug in f sub r and f sub theta. 2r cosine theta, negative 2r sine theta is going to be 1 plus 4r squared cosine squared theta plus 4r squared sine squared theta. I'm going to take 4r squared and 4r squared as a common. Cosine squared plus sine squared is going to be 1. So here is 1. 1 plus 4r squared. Because this one plus this one equal 1. R dr d theta. Now I'm going to assume this one here is u. du is going to be 8r dr. Divide both sides by 8. So du over 8 is going to be r dr. That means this one is going to be du over 8. We're going to plug in this one u, du over 8. Take the 8, 1 over 8 as a constant. Now we need to find the integral from 0 to 2 square root of u du. So let's keep going. So 1 over 8, u is 3 over 2. I did the integral with respect to the u, so because we have square root of u, so it's with u to the half. Now do the integral is going to be u 3 over 2 divide by 3 over 2. Flip this one 2 over 3. Cancel 2 with the 8. 3 times 4 is going to be 12. So 1 over 12. Now let's bring back the u, which is 1 plus 4r squared to 3 over 2 from 0 to 2. Plug in 2. So 1 over 12, 1 plus 4, 2 squared to the 3 over 2 minus 1 plus 4, 0 squared. So this, the whole thing here is 0 except 1. So from this side is going to be, this is 4 times 4, 16 plus 1 is going to be 17, 3 over 2 minus 1 and 3 over 2. 1 and 3 over 2 is going to be 1. I'm going to take the square root of 17. The left is going to be 17. That means 17 square root of 17. Now everything here is a constant. So from 0 to 2 pi d theta. 1 over, this is the constant, theta from 0 to 2 pi. Then is going to be 2 pi minus 0. Cancel the 2 with the 12. So pi over 6 bracket 17 square root of 17 minus 1. So this is the answer for example 3. Let's plug in here. It's going to be pi over 6. Now we're going to put a bracket or parentheses 17 square root of 17 minus 1. Out minus 1. Here we go. We got a tie. Let's go to example 4. So example 4. So let's see this example. Find the area of the surface, the portion of the plane z equal to 24 minus 3x minus 2y in the first octant. So z equal 24 minus 3x minus 2y. That means f of x equal 24 minus 3x minus 2y. So I'm going to let z, I need to grab this one. I'm going to let z equal 0. So 24 minus 3x minus 2y. Move the 2y to the other side. So 2y equal negative 3x plus 24. Divide by 2. So y equal negative 3 over 2x plus 12. Now, how to grab this one? The slope is negative 3 over 2. This is the intercept. That means you're going to go 3 points down and 1 to the right. 3 down and 1 to the right. If you want to graph it like this one until you find the x-intercept, it's up to you. Or you can graph it by finding the intercept for this line. How to find the intercept? You're going to let x equal 0. The y is going to be 12. If you plug in 0 here, the y is 12. So the first point is going to be 0, 12. This is the y-intercept. To find the x-intercept, you're going to let y equals 0. So this is 0. Solve it for x. X is going to be equal 8. That means the x-intercept is 0, 8, and 0. That's why I have these 2 points here. So now this is the region R. Now we can locate the boundary for the integral. For the x is going to be from 0 to 8, and for the y is going to be from y equals 0 to this line, which is negative 3 over 2x plus 12. 1 plus f sub x squared, f sub y squared, dy dx. F sub x is negative 3, f sub y is negative 2. Plug in these two here. Squared is going to be 9 plus 4, 13 plus 1, square root of 14, dy dx. Then find the integral with respect to the y. So it's going to be y from 0 to negative 3 over 2x plus 12. Plug in these, square root of 14, negative 3 over 2x plus 12, minus 0. This is a constant. Find the integral with respect to the x. So it's going to be negative 3 over 2, x squared over 2 plus 12x from 0 to the 8. So it's going to be square root of 14. Simplify this one. Negative 3, x squared over 4 plus 12x from 0 to 8. Plug in the 8, so it's going to be negative 3 times 8 squared plus 12 times 8 minus 0. 64 divided by 4 is going to be 16 times negative 3, which is negative 48. And 12 times 8 is going to be 96. 48, 96 minus 48 is going to be 48, square root of 14. That's it for this. So we're going to type here 48 square root of 14. Let's go to example 5, the last one. Example 5. So the portion of paraboloid z equal 36 minus x squared minus y squared in the first octant. So z equal 36 minus x squared minus y squared. And half of the x equal, I'm going to take the negative sign out. So it will be x squared plus y squared. Let's graph this one. I'm going to let this equals 0. Move the x squared and the y squared to this side. So it's going to be circle with radius r equals 6. But they're telling you find the region with the first octant. That means this one. R equals 6, and it's going to be with the polar coordinate. So we have to convert this one to the polar coordinate. Again, if you want to find f sub x, f sub y, then convert it to the theta, or you want to convert the z and then find f sub r and f sub theta. So our radius between 0 and 6, and the theta from 0 to pi over 2, because we need to find the region only this part. F sub r sub theta, this is r, so it's going to be 36 minus r squared. dy dx is going to be r dr d theta. F sub r with r theta is going to be negative 2r, and f sub theta is going to be 0, because there is no theta here. So our surface to the area from 0 to pi over 2, from 0 to 6, 1 plus f sub x, f sub r squared, and f sub theta squared. Negative 2r squared and 0. So this is 0. From 0 to pi over 2, from 0 to 6, 1 plus 4r squared. r dr d theta. I'm going to let this one equal u. So let u equal 1 plus r squared. du is going to be 8r dr. Divide by 8. So it's going to be du over 8 equal r dr. Now plug in this one u, and r dr is going to be du over 8. Take 1 over 8 out. The integral from 0 to 6 square root of u du d theta. Then the square from 0, and here is pi over 2. Find the integral for the u to the power half. So it's going to be add 1, so it's going to be 3 over 2 times 2 over 3, because it's over 3 over 2. I'm going to flip it, 2 over 3. Take 2 over 3 out, so it's going to be 1 over 12, because 1 over 2 over 24 is going to be 1 over 12. And bring back the u, so 1 plus 4 r squared to the power 3 over 2 from 0 to 6. Let's keep going. Let's keep going. So 1 over 12, I'm going to take it out as a, because it's constant, from 0 to pi over 2. 1, we're going to plug in the 6. So 1 plus 4, 6 squared to the power 3 over 2 minus 1 plus the 0 squared. So this is going to be 0. That means 36 times 4 plus 1. So it's going to be 144 plus 1 is going to be 145 to the power 3 over 2 minus 1 to the d theta. The whole thing here is a constant. Take it out from 0 to pi over 2 d theta. So it's going to be theta from 0 to pi over 2. So plug in pi over 2. So it's going to be 2 times 12 is going to be 24. Here's the pi. You can take this one is square root of 145, because power 1 over 2 and 145 to the power 1. 1 plus half is going to be 3 over 2. So it's going to be 145 square root of 145 minus 1 over 24, and the pi here. So let's check this one. So we're going to plug in pi and the brackets 145 square root of 145 minus 1 over 24. That's it for this section.